All right, folks, so in this example, guess what? More examples, because I want you to be an expert, and I want you to go out and teach organic chemistry after you get this class completed. And you probably have looked at some of my tests and probably have wondered that across the course of the semester at this point. All right, so let's take a look at another example. This time I'm just going to do a little ziggy-zaggy line like this. We'll put a hydrogen over here to the right and a double bond O here, and then on the left we'll put a double bond O there. All right, so let's take a look at this kind of molecule and figure out what we have and how to name it. And if you look at this example problem, I've given you two functional groups. The C double bond OH. Well, that's the aldehyde that we learned just a little while ago. And then over here to the left, this is a carbon double bond O that's sandwiched in between two carbons. So therefore, this is a ketone, folks. So we have two competing functional groups. Which one gets the priority? Well, I go back to the magic chart that I've kept referring to this whole time. And if I take a look at this chart and figure out which one gets the priority, is it the aldehyde or is it the ketone? Well, if I look at the aldehyde, both of those are grouped here, and then right below is the ketone. So what this is telling me is that the aldehyde takes priority. That's how we do this, folks. So the aldehyde means that I'm going to end the name in the AL ending because I'm going to name it as an aldehyde. And then the ketone part, I'm going to have to name the ketone part in some form or some fashion, and what we do is the prefix name. We name it like a substituent. So wherever the ketone is showing up, we're going to use the oxo name. Now look at this. The aldehyde, one version is strictly just the oxo because we said that carbon is part of the main carbon chain, and because of that, the main carbon chain takes care of that carbon, and we're really just naming the double bond O. And actually, that's kind of what we're doing here in this example as well. We're just naming the double bond O piece, so we name it the same as we named it with the very first aldehyde that's listed on the chart. So oxo is going to be the go-to prefix here. All right, so the Iupac Rules say, find the longest carbon chain. All right, so if I'm naming it as an aldehyde because that takes priority, well, there's the first carbon, there's a second carbon, there's a third, there's a fourth, and there's a fifth. So we're going to name this pentane, drop the E and add O-N-E. So this is a pentanone, right? Wrong. That is wrong. There's a ketone there, but we're not naming it as a ketone. I just told you we're naming it as an aldehyde. So instead of the O-N-E ending, I need the A-L ending. That is the aldehyde Iupac name. So we're naming it as the aldehyde. Aldehyde starts with Al, so therefore we use Al in the ending of the name. Pentanal is going to be the parent name. Now we still have to name the ketone. The ketone is there, but we have to name it using the oxo prefix. So at carbon number 1 and carbon number 2 and carbon 3 and carbon 4 and carbon 5, I've numbered that way because that ending is closest to the ending of the aldehyde group, and that's how we number it. So at carbon number 4, I have the oxo piece. So 4-oxo pentanal is going to be the Iupac for this name. There's no common name because there's multiple functional groups that are there. Common names really don't play a factor here. So the more complicated it gets, the less of a chance I'm going to see a common name associated with these molecules. All right, so let's take a look at another one. We'll do another zigzag, zigzag, and then an OCH3 here at the end. We'll do a double bond O there, and we'll do a double bond O here. Okay, so just like before, we'll identify the functional groups because only then can I really make a decision on how to name this. That's the very first step in doing these all the time. So if I look at this carbon, it is a double bond O, but there's an O right beside of it. So this double bond O, folks, makes this have a ester group. There's an ester group on the molecule, but that's not the only group. There is another group as well, and that is just the simple double bond O on the left hand side. So just like before, this is also a ketone. So I have a ketone and I have an ester, and I've got to kind of figure out which one I need. I don't need the chart. The reason I don't need the chart, folks, is because that ester is a type 1 and that ketone is a type 2, and we said type 1s typically have higher priority than type 2s do. So if I go back to that chart, I'm probably going to see ester listed above a ketone, and that's one of the reasons we already kind of predicted this. And if you go back and look, you're going to see that I'm telling you the truth. Can you believe it? All right, so we've got to go through and name this as a ester piece. Well, ester. How do we name the ester? Well, you name the group on the O first, and that's what we'll do here. So that CH3 is a methyl group. So there's our first step. And then you find the longest carbon chain. All right, so there is a 1 carbon and a 2 carbon and a 3 carbon and a 4 carbon. So there's 4 carbons that are going to be there. So those 4 carbons in total makes this a butane. Drop the E and add O8 at the end. So butanoate is going to be that name. Now, we're still leaving off a part. I'm just kind of assembling the pieces, and we'll put it all nice and pretty a little bit later. So a methyl group is there, and a butanoate is going to be there, and then a C double bond O. So if I look at the chart, just like before, we named the double bond O using the oxo unit. All right, so this is carbon 1 and carbon 2 and carbon 3 and carbon 4. So on carbon number 3, we have a double bond O, and that double bond O is going to be called an oxo. All right, so this is a 3 oxo unit. So here are my pieces. I need to put it together in form of the proper structure of the name. We're naming it as a ester. So ester rules state you do name the piece on the O first. That is what you should be doing. So that is going to be methyl. Now everything else on the other side of the ester gets named together. Well, we have a 3 oxo, and then the butanoate. So methyl 3 oxo butanoate is going to be the Iupac for this structure. All right, folks, so there you go. There's another molecule, 2 functional groups, different functional groups, and this is how we make the decision in order to name them. All right, let's do another example. This time we'll do a ring. Yeah, we don't really do rings too much. We typically forget about them, but I'm not going to let you forget about them, am I? So a ring system with a double bond O, and then a 1, 2, 3, 4, 5, and then a double bond O here. All right, so we've got to figure out how to name this, and this is going to kind of force us to go back and dig into the older ways that we named more complicated groups. Now, what do I mean by that? You'll see that in just a second. So let's figure out what we have here. All right, so what we have going on for us. Here is a ketone. Well, that's great. And then here is a ketone. All right, so we have a tie. So maybe, just maybe, we have a dione that is present. So my mind is already thinking, okay, I'm going to figure out the longest carbon chain. At the end of the carbon chain, there's 2 ones, so that's a dione at the end of the name. So hopefully I'm right. Well, you're not going to be. So the reason, let's kind of talk about the reason. Longest carbon chain. That's where we need to start with this. All right, so the longest carbon chain, a 1 and a 2 and a 3 and a 4 and a 5, and then it connects to this ring. I really can't include that ring as part of the main chain. they are somewhat different. We saw this back in Chemistry 251. So the longest carbon chain, folks, is really just that. It's got to be a chain of carbons that cannot circle back around on it, meaning you can't include a ring as well as a straight chain. It's got to be one or the other, and you've got to figure out which one you've got. So this is a 5-carbon chain, and then on the other side, we treat this as its own, and there is a 6-membered ring that is here. So 1, 2, 3, 4, 5, and 6. So if I have to pick out the longest carbon continuous chain, it can't be both morphed together. There's no such thing as a hybrid like that. It's either straight chain or it's the ring, and in this case, the ring has more carbons than our straight chain does. So this parent name is going to be a cyclohexane, drop the E and add one. All right, so cyclohexanone, well, that's because this is understood to be the one position at that point. If I identify the ring as the main parent chain, that functional group automatically gets position number 1. That's just how any functional group would work, and it does so here with the ketone as well. So if I look at the ketone, and this is spot 1, that means this is spot number 2. We've got to go back and we've got to figure out how to name this group. Okay, well, if this was just a 1 carbon, 2 carbon, 3 carbon, 4 carbon, I could just put 2-butyl there and call it a day. Yay! Yay, I'm done. But it's not. This is a 4-carbon chain with another functional group on it as well. And we talked a little bit about this in Chemistry 251. In Orgo 1, we mentioned the ways that we handle these more complicated types of groups. So what I need you to kind of go back and dig up and remember is that we have to treat this group as its own, really. So in other words, if I asked you 1, 2, 3, 4, 5, this is actually a 5-membered ring, not a 4. I think I said a 4 a while ago. All right, so this 5-membered ring, if I asked you, forget about the ring, don't even look at it. Just look at this substituent piece. How would you name this? Oh, well, Tracy, that would be pretty easy. 1, 2, 3, 4, 5. So this is a pentyl, right? A pentane. And we would drop the E, and we would add an one, right? Pentanone. And then we would say, hey, this pentanone is going to happen at carbon number 3, no matter which way I go with it. Okay, well, if you do that, you're close. And the reason is because that would be if that group was just that group only. But this group is a substituent. It is not the parent chain. It's not the longest chain. This is a substituent that gets hung off of the molecule. So we can't really use own. We have to use this pentyl. All right. Now, some people will use pentanyl, but if you go back and take a look at methyl, ethyl, propyl, butyl, pentyl, that's really more proper here. So this is a pentyl ring, or not a ring, but a chain that's hanging off of the ring. So it's a 3-pentyl. Well, what's at 3? Well, this is where it is attached. So that's carbon 1 and carbon 2 and carbon 3. And what we have here is a oxo, right? At the 3 position, I have a carbon double bond O. And we've already said that's the oxo piece. So this substituent, it's a little complicated. It's a little bit beefier than some of the others that we've talked about, but we can still handle it. And we handle it by treating it separately. So a 5-carbon piece is hanging off, and that's called a pentyl. And then on the 3rd carbon of that 5-carbon piece, we have a oxo unit. Now, there's one more thing that I have to do. I've got to put this in parentheses, right? And the reason I put it in parentheses is because this unit as a whole is attached to carbon number 2. So the Iupac name for this structure is going to be 2,3-oxopentyl cyclohexanone. That means parent chain, cyclohex, 6-membered ring structure with a double bond O. And at carbon number 2, bing, 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 right there, we have a pentyl group, 1, 2, 3, 4, 5. And then on that third carbon of the pentyl group, we have an oxo piece, which is a double bond O. So a little bit more complicated than some of the others that we talked about. We have introduced this in Chemistry 251. It's just a matter of going back and digging it all back out of those rusty, dirty, dusty folders in the way, way, way nether regions of your brain. All right, so there we go. Hopefully that was a review. If not, you just learned something new. So, tuition dollars at play. Congratulations, you got your money's worth. All right, so let's keep going. Let's do a CH3 and a CH2 and a CH2 and a carbon double bond O, and then another CH2, and then a CH2, and then a CH3. All right, so this one's kind of good, right? We just have one functional group. That's it. That's all we have to worry about. This one should be wrap it up. Let's go. And I promise you that it will be. So if you look at this double bond O, it's in the middle. We know that this is a ketone. We find the longest carbon chain. 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6, 7. I counted wrong. So this is a heptane. Drop the E and add -one. Okay, well, where does that ketone group happen? 1 and a 2 and a 3 and a 4. And if I go the other way, guess what, folks? It's another and a 1 and a 2 and a 3 and a 4. So it's a 4 no matter which way we go. So 4-heptanone is going to be the Iupac. However, are we done? And the answer is yes. We are finished with this molecule. There's nothing else that's hanging off of it. I told you that this would be pretty simple. Now, I can also provide a common name for this. A common name for this is going to be pretty easy if you remember the common nomenclature. So C double bond O, that is going to be the name of the ketone. So I put ketone into the name. And then I name the piece on the left and I name the piece on the right. And in each case, it's the same here. So I don't want to call it propyl ketone. What I want to do instead is call this a dipropyl ketone. And folks, there you go. So dipropyl ketone is going to be the common name of that molecule. All right, so let's do another example. Let's keep going. Let's keep going. I know you're liking these, right? I mean, you're having fun with these. It's like going out with me on a Friday or a Saturday night. You're having so much fun, you just don't want it to stop. All right, so C double bond O, and then a CH2, and then a CH2, and then a CH3. All right, so this carbon here I've left off on purpose. This is a CH3. That's a CH3. This is connected to a CH2. So my fourth bond is going to be a hydrogen right there. Okay, so let's go through and name this piece. Well, we really only do have one functional group. I know there's a methyl group hanging off, but that's not really a functional group, is it? That's not an alcohol and a ketone and an aldehyde and everything else that comes along. All right, so we have a ketone. This ketone is going to get priority, and we're going to find the longest carbon chain. That includes the ketone piece. All right, so the longest carbon chain probably looks like this. 1, 2, 3, 4, 5, 6, and 7. Okay, so it looks to me like it's another 7 carbon chain. I mean, how exciting can it get? All right, so 7 carbons in total. We know because of that, this is a heptane. Drop the E and add ONE for ketone. All right, so heptanone is going to be the parent name, but I've got to tell you where the one is located. All right, so if I start from the left, a 1 and a 2 and a 3 and a 4. And if I start from the right, it's still a 1 and a 2 and a 3 and a 4. So it's a 4 no matter which way we go. There's no question about that. So 4-heptanone is going to be the name of that piece at least. And now we have this other group that's attached, and this other group is the methyl group that I have not named yet. So I need to go in and I need to name it. Well, now we do see a difference, because the methyl group is pushed toward the left-hand side. So the ketone group, it was a tie. It really did not matter which way I numbered it at that point, and it was a 4 no matter which way we went. The methyl group, though, is going to force the numbering of the carbon. And the reason is because that methyl group is toward the left-hand side of the molecule, and that means that we number to the left-hand side of that molecule, and that means that this, sure enough, is number 2. So at the second carbon, we have a methyl group. So 2-methyl 4-heptanone. All right, now can we common name this? Of course we can. All right, so there's the C double bond O, and that is the ketone piece. This over here on the right-hand side, this is a propyl. Okay, well, what is this over here? It looks a little complicated. I can't name that. Yes, you can, because this is a carbon-carbon-carbon that makes an L at the very end of the molecule, and this always makes an iso unit. So what type of iso unit is it? A 1, 2, 3, 4 in total. So this is a isobutyl group. So if I put the two pieces together, here is the isobutyl propyl ketone, and that is the common name for that molecule. All right, so let's do another example. We're on a roll. We'll keep going. We're not going to waste any more time. Wasting time? I think you've wasted my time all semester is probably what you're thinking right now. CH3, CH2, 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 and a carbon and a double bond O, and a CH double bond CH2. Look at there. Look at what I've done to you. Okay, so in this molecule, we have 2 functional groups yet again. So we've got to go back and we've got to figure out how on earth to handle this. C double bond O in the middle of a molecule, that's called a ketone. You're not going to get me on that one. I hope that's at least what you just told me. And that double bond, this is an ene group. So I know I have an one, and I know I have an ene, and I know I need an Iupac. All right, so here we go. There's our molecule. My pieces are coming together. And which one is going to take priority? The ketone or the alkene? Well, once again, if you need to know that information, use the handy dandy chart like Blue's Clues. If you don't remember Blue's Clues, then you probably did not grow up in the 90s. I didn't grow up in the 90s, but I still know what Blue's Clues is because I had nephews and nieces. All right, so if you look at the chart, alkene is down here toward the bottom, and my ketone is above the alkene. All right, so what that means to me is that the ketone will take priority over the double bond. Okay, so longest carbon chain, that includes ketone. I don't really care about the double bond at this point. If it includes the double bond, then it includes the double bond. So be it. I just need the longest carbon chain with the ketone. All right, well, if I do that, carbon, 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 carbon. It just so happens to include the double bond. Okay, well, that's great. That's perfect. So the total number of carbons here is a 1, 2, 3, 4, 5, 6, and a 7. Oh, goodness gracious, another 7. That's right. So this is a heptane. Drop the E and add O-N-E. And then if we follow suit like we've done everything else, heptanone, where is that heptanone? I need to give it the lowest number wherever the ketone group is going to be located. So the one right now includes the ketone, and 1 and a 2 and a 3. Or if I go the other way, that's a 1, 2, 3, 4, 5. That's silly. Why would you go from the left? Because that gives you a higher number, doesn't it? So we're going to number from the right-hand side, and that means that at carbon number 3, I have my own group, my ketone, because I'm naming it as a ketone. I need you to understand that. You're probably thinking, well, wait a minute, a while ago we named this with an oxo. The reason that we did that is because that was a substituent. That was not the main parent chain. That was not how we named the molecule. That particular type of group at that point in time, something else beat it out, like an ester group, and we named it as an ester. In this case, ketone does take priority, and because of that, we end in "-one", and that means that ketone is included in that name at that point. All right, now, the other functional group that we have is a double bond. That double bond is a "-ene", and I need to incorporate that into the name in some form or fashion. So enes typically go at the ends of the name. That's how we treat them. So I've got a big problem here. What I have is a "-ene" ending that I need to convey to you in the name, and that "-ene" is actually going to happen at the very first carbon. So I need a 1-ene conveyed in the Iupac name. That way you know that at the first carbon of this structure, we have a double bond in addition to the ketone group that we have at spot number 3. So I'm going to have to do some reorganization here. So I'm going to have to that "-one" ending, and this heptane, well, it's not really an "-ane", is it? Nuh-uh, no way, no how. Instead, this is a "-e". So I need to convert that to a heptone, not a heptone. I know, slight modification, slight difference, but that's just the way that it is. Well, I need to get rid of the 3 because the 3 right now would go to the double bond. My double bond is not at number 3. My double bond is at number 1. So 1 heptone, I'm going to have to change the beginning of the name that way because this 3 position will have the "-one" ending for my ketone. So 1 heptone, 3 "-one is the name of that molecule. All right. Now, some of you maybe want to be lazy. That's okay. No one says that you can't. And you're like, well, you told us that anytime something happens at carbon number 1, we didn't have to write the number, and now you're writing the number. Okay, well, that's true. We can get rid of that if we want to, and you can just report heptone 3-one if that's what you want to do. That's perfectly fine with me. I've got no quarrels with that. So 1 heptone 3-one or heptone 3-one, folks, there you go. There is the Iupac name for the structure. However, we're not done. And the reason is because we can common name this as well. What? Yeah, we can common name this. We know what these groups are called. We learned this in Chemistry 251. What do I mean by that? Well, that C double bond O can be called the ketone. At least I hope you can get that far. All right, to the left of this is a 1, 2, 3, 4 carbon chain that's called a butyl. That was not a problem there. To the right of this, though, you're probably looking at this one and you're saying, well, wait a minute, what is that called? Do we know a common name for that? Is this called a ethane? No, it's not called an ethane. A carbon double bonded carbon attached to a main chain. We have a common name for that, folks. We had a common name for a carbon double bond carbon attached to a main chain, and we had a common name for a carbon on a carbon double bonded carbon attached to a main chain. This was way back when in the Alkene lecture. One of the very first lectures of nomenclature that you received in Chemistry 251. If you don't remember what these are called, let me make it easy for you. I'll bring it up. This carbon double bonded carbon was called the vinyl group, and the carbon double bond carbon carbon onto a chain was called the allyl group. Look at there. Okay, so this is going to be called a butyl, and then a vinyl ketone. Butyl, vinyl, ketone. There you go, folks. That is the common name for that molecule. All right, so with that said, we will stop here. We'll pick back up with examples in the next video. We'll keep doing nomenclature because this is an area where a lot of people struggle with. And then after the nomenclature, we'll take a look at a few of the reactions on these top 2 carbonyls.